All right, so for example number 2, let's look at our periodic table and equation sheet. Our delta G equations are down here in the thermodynamics and electrochemistry section. You've got delta G from delta G of formation. You've also got our delta G formula we just used, delta H minus T delta S. But we've also got this one, delta G is equal to negative RT ln K. And then we'll use this one later, negative in Fe. So delta G equals negative RT ln K. We're going to use that equation. Now, when you use it, you're going to need to be careful with which R value you use, the gas law constants. And gas law constant, R value, is going to be in the gases section, gases, liquids, and solutions. So move over there and look down to where R is, and you see 3 values again. Well, we usually use this one, atmospheres per mole Kelvin. That's what you usually use when we're doing gas laws, because we usually have atmospheres. When you're doing a problem with thermodynamics, we're dealing with joules and kilojoules and that type of thing. You want to use the R value with a unit you recognize that's easy to convert with thermodynamic units like joules and kilojoules. So we're going to use 8.314 joules per mole Kelvin. 8.314 joules per mole Kelvin. So let's go ahead and set up, first of all, that equation, and I've just kind of copied it. I'll paste it right there. Delta G equals negative RT ln K. All right, and we're going to need a few different values. So delta G is given to us. That's negative 257.2. And it's set equal to negative R, which we just looked up. It's 8.314 joules per mole Kelvin. Joules per mole Kelvin. Now let's be careful here. I almost made a mistake because this is joules per mole Kelvin. This over here is in kilojoules. I need to convert that into joules. So that means I would multiply this number by 1,000. 1,000 joules go into each kilojoule. So if I have 257.2 kilojoules, that's 257,200 joules, which is what I need if I'm using 8.314. So my delta G equals negative R times T. My temperature is 25 degrees Celsius. Don't forget, it needs to be Kelvin. So add 273. 25 plus 273 gives me 298 Kelvin. And then we're going to do ln of K. So I have negative RT ln K. And I'm going to solve for K. Now, you might not be real familiar and comfortable with logarithmic properties. I hope you are, but if you're not, we'll walk through that because I'm going to have to figure out what this is, what the value of K is. I'm going to have to do the inverse of ln. We'll get to that in just a minute. First, let's clean it up and do some of the easier math. So if I just copy and paste this down on the next line, this negative 8.314 times 298, let's see, it comes to negative 2,477.572. Don't worry, we are going to round to 3 sig figs in the end, so don't forget to do that. But we'll round to 3 sig figs at the end since it's 25 degrees Celsius, which is 298 Kelvin. Okay, next thing I need to do is divide. I'm going to divide those numbers. So if I have a, oh, and this is not negative. It's not negative. It's just the negative one time. Negative 2,477.572. So divide those numbers. Negative 257,200 divided by negative 2,477.572. You end up with 103.811312, and I'm not going to write all of that, equals ln of K. Now, to do the inverse of ln so that I can end up with just k, I'm going to have to remember something. The inverse of ln is e to the power of. So in other words, x equals e to the power of ln of x. It's a property that you need to know about logarithms. X is equal to e to the ln of x. One way of remembering that is that the inverse is often the second button on your calculator. So when I want to do the inverse logarithm, or the inverse ln, I just push second ln, and you can see that that's e to the x. So if I want to undo this, if I want to solve for k, k is going to equal e to the 103.811. If you put that in your calculator, you end up with 1.21. So k is 1.21 times 10 to the 45th power. Now that's a huge, huge number. What that means is, if the k value is bigger than 1, that means that it is a process that favors products. We're going to make more products. If delta G is negative, that's a favorable reaction in the forward direction. So this is consistent. Our answer is consistent with the prompt. It's a good thing to always check that type of thing. Let's do number 3. The equilibrium constant, K, of the equation above is 1.42, and the delta S is negative 138.5 joules per Kelvin mole at 25 degrees Celsius. Calculate delta G and delta H of the reaction described above. Okay, so we can think about a few different things that we could do. First thing I recognize is I have K and I need delta G. There's an equation that gets me delta G just from knowing K and the temperature. That's what we just used, so we're going to start with that equation. Delta G equals RT, negative RT ln K. So delta G is going to be equal to negative, R is 8.314. T is going to be, it's 25 degrees Celsius, which you add 273, that's 298 Kelvin. It's a pretty common temperature for them to use. And then we have ln of K. Well, I have a K value, so I'm just going to plug in my K value. The equilibrium constant, K, for the equation is 1.42. I hope you can recognize that this should be a negative value because I have a equilibrium constant that is bigger than 1. So now let's go ahead and just plug that in a calculator and we'll find our answer. I get negative 869, if I'm rounding to 3 sig figs, negative 869 joules. Okay, so that's my delta G, is in joules. I'm also looking for delta H of the reaction, and I have delta S in joules per mole reaction. So remember, another equation that we have learned to use is that delta G equals delta H minus T delta S. That's going to help us to solve this problem. And we can just plug in some numbers down below. Delta G, we just figured out, is negative 689 joules. Pay attention to what the units are. These are joules, not kilojoules. Delta H is what I'm looking for. I have a temperature of 298 Kelvin. I already figured that out for my equation up here. And then delta S was given to me as negative 138.5 joules per Kelvin mole. Okay, so that's joules, which is what I have down here. I just need to always check to make sure that's consistent. And we're multiplying these numbers together. So remember to make sure you're multiplying. So delta H minus T delta S. Just going to kind of clean that up a little bit. So if I multiply these numbers by each other, then I would be subtracting a negative 41,273, or you could say I'm adding 41,273. Okay, so now if I want to find out what delta H really is, I'm going to have to subtract. I'm going to have to combine my terms. So delta H will equal, it's going to be negative 869 minus 41,273, which is going to give me negative 42,142. If I wanted to round it to 3 sig figs, it's going to be 42,100 joules equals the delta H value. Now, often they'll actually ask you to put this in kilojoules. Kilojoules or kilojoules per mole of reaction. Enthalpy is just often in kilojoules, so that would be 42.1 kilojoules if they had asked. It didn't really say that it needs to be in kilojoules per mole though. So we found delta G, and then we found delta H. So there's 2 steps to solving this, and there are both of your answers right there.